So then you can.
Alrighty, good morning, everybody, and welcome to Coffee with a County Forester. My name is Lisa Sawsville, and I'm with Vermont Coverts, and I, along with Kathleen Warner with Vermont Woodlands Association, have been bringing this program to Vermonters for the last 6 weeks. And it's been great to feature all these county foresters. There's 14 of them around the state. And today we feature Dave Paganelli from Orange County. And I'm going to just turn it over to Dave. What I ask all of you to do is to mute yourselves so we don't have the background noise. If you have a question, you can type it in the chat box and I'll refer them to Dave, and we'll kind of keep it that way so that people aren't talking over each other. And if you need clarification, you always turn your mic on and clarify a question if we haven't quite got it all there. Anyway, so that's the intro. And Kathleen, do you have anything to add?
Let me take my mic off mute. No, just to say good morning. Thank you all for being here. It's been really exciting to host these Friday morning chats with our county foresters. Everyone is a little different, and I always learn a little something new. So thank you, David, for joining us today.
Oh, you're welcome. My pleasure. Thanks to everybody who is taking time from their morning to spend it with us. We appreciate it. Just a little background. I grew up in the Connecticut River Valley in Connecticut, got a forestry degree from the University of Idaho, grad school at Virginia Tech, and then came to New Hampshire to be an extension agent, and then ultimately came here to be the Orange County Forester, and have been doing this for a little over 31 years now. I remember when I first started and was the new kid, and now I'm the old man, and I guess that's the way it works. It's a great place to work, and the forest here is wonderful and diverse and productive, and it's been wonderful. And as county forester, we primarily administer the current use program. Current use program being a tax program that helps forest land and agricultural land in Vermont be taxed at a fair rate. And also, county foresters work with towns to manage municipal forests, town forests, community lands. And, you know, we do educational programs like this, either independently or with our partners like Vermont Coverts and Vermont Woodlands Association. And, you know, there's a lot going on, and it's a fun place to work and fun job to do. What I hope for today is that we can interact. I don't really want to talk to you for an hour. I would rather that we get some kind of a conversation going where we have a back and forth and questions and comments, and everybody that wants to get involved can get involved. That would be the best. That would be the best outcome for this morning. And I have, you know, some topics that I can talk about. I could talk about invasive plants or forest management or climate change ad nauseum. But I think what I'd like to do is just to break the ice, talk a little bit about trees. So as a forester, my job is to try to understand what goes on in a forest. And trees are the dominant plant, but there's a lot more going on in a forest than just the trees. There's all the animals and the birds and the microbes and the insects and the salamanders and the, you know, I mean, lichens, mosses, wildflowers, everything is part of the forest, the soil.
Yeah.
And so let's talk a little bit about trees just to get something going. So I'm looking out my window and I can see mostly hardwood trees, none of which have leaves, except for beech trees. And beech trees have leaves from last year, small beech trees. So that's kind of interesting that a species holds its leaves all winter. So one might ask the question, why? Is there some benefit to holding dead leaves all winter? And I'm not going to answer the question right now. I'm not sure that I know the answer, but you know, that's something that I see. And then I look and I see some of the trees, in my view, have green leaves. So those are the white pines. So we have all these hardwood trees that have no leaves. And we have, right now, we have plenty of moisture in the soil. The soil is thawed. There's plenty of, you know, sunlight, not necessarily today, but there's plenty of sunlight. There's plenty of water. There's warm enough temperatures to photosynthesize. And some trees have green leaves and are prepared to do that. So that's pretty interesting. It makes you wonder why more plants aren't ready to photosynthesize, but the pines are. Another thing that I look at is the color of the bark. Now, if you're like me, when you first learned to draw a tree, there were two basic types of trees. There was the triangle, which was the softwood trees, and there was the lollipop, which was the hardwood trees. And they were all green, all the same color green, and they all had brown stems. Well, if you look out at the trees that are around you, you will seldom see a tree with a brown stem. Most of the trees that I see have gray stems. And there are a few that have white. Paper birch has white bark, yellow birch has golden bark. And the white pine, let's go back to the white pine that has the needles that may be photosynthesizing today, when everything else is still dormant, or more or less dormant. A lot of those white pines have green bark. Green bark. Well, what makes them green? Chlorophyll. So the bark photosynthesizes. Think about that. Interesting. Because we usually think of leaves photosynthesizing, but really anything with chlorophyll photosynthesizes. So that's a competitive advantage at some times of the year. You usually see that more in small trees than large trees. And usually you see green bark in what are called shade intolerant species. So white pine is kind of it's tolerant of some shade, but not too much. But trees like aspen or serviceberry or striped maple often have chlorophyll in their bark. And those are small trees that often grow in the lower levels of the canopy where light is precious. And so when they get light, they want to be able to use it and they want to be able to maximize it. So that's an interesting concept. And all of this stuff, all of these little tidbits, they factor into a concept called natural selection. So natural selection, I think probably most of us know what natural selection is, but it's a process where species exhibit some variability. You know, think of the people around you and how different they look and the physical characteristics that they exhibit. And plants are the same way. And in any plant species, let's say sugar maple, has variability. So there's a difference in the shape of the leaves, the size of the leaves, the thickness of the leaves, the thickness of the bark, the pattern of the bark, you know, like our skin. When they break bud, there's variability. And if a particular characteristic affords an advantage, then that characteristic often is carried forward in the species. So if there's a genetic mutation that causes some new characteristic and it benefits the tree more than the population at large, that characteristic, that individual with that beneficial characteristic will reproduce successfully and that characteristic will grow within the population. So that's, you know, that's how we get white bark on a tree. That's how we get yellow bark on a tree. That's how we get green bark on a tree. Is something happened that caused a different kind of a bark that was beneficial in whatever circumstances that tree grew in, and it successfully reproduced, and you have a characteristic that carries forward into the future. So that was the icebreaker. Does anybody have a comment or a thought or a question on that or anything else? I'll give you a chance to say something.
So Dave, there are a couple questions in the chat box.
Okay.
John Bingham wants to know, what are the top 3 changes that you've seen over your 31 years as the Orange County Forester? And what is the significance you associate with each of them?
Wow, that's a great question. Well, there have been a lot of changes. And of course, there are changes in society. This is a different place than it was. The culture is different here. The roads are different. I remember 30 years ago, the roads were narrower, especially the gravel roads. When you were on back roads in Orange County, you often had to slow down and find a place to pull over when another car came, because the road wasn't wide enough for 2 cars to pass at normal road speed. And now they're all wider. We've widened our roads. So that's just one thing. And when you widen the roads, you cut the trees that had traditionally grown at the edges of the road. So those big maples that we kind of have in our image of a Vermont back road, a lot of those trees got gravel pushed around their base as the roads were widened. They eventually died and were removed, and now our roads are wider and sunnier and probably dustier as a result of less shade. That's one thing. In the forest, I would say it used to be easier to regenerate sugar maple. So from a forest management standpoint, what you're often trying to do is to replicate natural conditions that are successful for a particular species. So sugar maple tends to regenerate naturally under partial sunlight. So there's a certain level of sunlight. If you think of the stocking in a forest from a dense, dark forest to a clear cut, somewhere right about in the middle is where sugar maple tends to regenerate the best. So if you have big, healthy sugar maples that are dropping seed and you have the right light conditions, 30 years ago, you got sugar maple. Today, not so much. Today, it's really hard to regenerate sugar maple. So the causes, climate change, probably, and that's a complicated topic, but the climate has changed enough that it is impacting the ability of sugar maple to regenerate. We have higher deer populations, and when sugar maple does regenerate, the deer tend to eat it in this place, and then the sugar maple eventually dies out, and the other species that regenerated along with the sugar maple that are not favored deer browse species tend to dominate the forest, like beech and ironwood, aspen, white ash to a lesser extent. So the composition of our forest, of our young forest, is different than it would have been if we did the same thing that we do today 30 years ago. And that has long-term implications for all of the species that occupy the forest, all the wildlife, all the mosses, lichens, insects, soil microbes, everything is different when you have a different tree community. So that's major. Another thing is that I see more red maple and more red oak and less sugar maple in the overstory. So the overstory being the large trees in the forest, the understory being the small trees. The overstory is, gradually being cut. Every time there's a timber harvest, big trees get cut, little trees replace them. And there are more and more red oak and more red maple, and less of other species. So that's just something that I do see. And I'll give you a fourth because I'm looking out my window. And invasive plants. 30 years ago, if you had asked me a question about invasive plants, you would have just gotten a dumb look because I wouldn't have known what you meant. Now I would know what you meant. Invasive plants are expanding across the landscape, and it's a little insidious because when they start, they don't seem like a big deal. Just a plant here, plant there. And there's plenty of room for a couple new species of plants. It's not a big thing. But then they reproduce really well. They break bud early. They hold their leaves late. They fruit almost every year. They have high germination rates. They can grow on a wide range of sites. They're really good plants, at growing and reproducing. And they're outcompeting a lot of our native plants, and they're changing our forest. And in some places, they're actually replacing the forest with a shrub community, which is pretty scary, if you think about the future. And again, not just from a tree standpoint, not just from, I love sugar maple and I love to be able to tap the sugar maple for sap, or I love to, cut saw timber and make money from my forest, but just from an ecological standpoint, if you change the very nature of the forest, change a forest from a forest to shrub community, you've changed everything. So that's a big change. That's globalization, to a lesser extent climate change, but mostly globalization. It's when we opened up our borders to products from all over the world, we brought in insect and plant pests at the same time. Then you have the invasive insects, which can kill particular species. And so you have all of that. I think milder winters is another change, and that's not all bad. I like winter, but 4 months of winter is fine rather than 5. And so plants like warmer conditions up to a point. So I think in general, trees are vigorous now. If we can, if we have a healthy community of native trees, they're actually pretty healthy right now. So I know that's a long roundabout. I probably did 5 or 6, but there you go.
Well, I think that leads into a couple other questions that are here in the chat box, especially the part about invasives with insects and plants. So I'm going to jump ahead a little bit and hit this one first, and then we'll go back a little bit to an ash question. So the first is going to focus on honeysuckle and buckthorn, and then or bittersweet, and then we're going to go back to ash.
Okay.
So Jeff says, I'm actively pulling honeysuckle, and I cut stump treated quite a bit of buckthorn in February. What plants and trees should I plant to benefit bird habitat?
I'm not an expert on birds. So I don't know, honestly, Jeff, I'm not sure I'm qualified to address that. We're doing a little planting this year of maple leaf viburnum, high bush cranberry, various dogwoods around our place. But my knowledge is really thin on that. So what I'm doing is I'm planting plants that other people tell me have value. And I'm not really sure. I mean, I know high bush cranberry and maple leaf viburnum have red berries. Red usually attracts birds. That's a natural mechanism. I guess birds can see red. And so a lot of the favored fruit for birds is red. That's also one of the strategies of the invasive plants. That's why barberry has a red berry. So, I mean, I guess I would say talk with Lisa, talk with Fish and Wildlife, talk with NRCS, the Natural Resource Conservation Service. They have programs where they will actually help defray the cost of planting bird-friendly species. Talk with Vermont Audubon, or Audubon Vermont. They would be more knowledgeable than I.
So a quick question there. If you're treating invasives, as long as you're treating them and keeping them out of the area, do you need to plant? I mean, or can we let things come in that that come in on their own?
Well, excellent question. There's a principle in treatment of invasives called integrated pest management, and it is trying to have a strategy to control the establishment of invasive plants that is more than just herbicide. So one of the strategies that one can use is to first you try to kill the invasive plants that you have, recognizing that there's a seed bed and they will be back. So you kill the big plants that you have, and then one of the strategies is then you try to fill the growing space with something else. So you can let it happen on its own, in which case the seed bed will germinate and you'll get mostly invasive plants back, but maybe a few native plants. Or you can be more proactive and you can say, well, I'm going to plant right in the middle of that spot where that big barberry was, I'm going to plant a high bush cranberry. And by the time the barberry kind of germinates its seed bank and starts to come back, there's going to be a plant occupying that space. So that's one strategy, is you basically fill the space with some native plant. I've done that here at my place with white pine. Not that I particularly want white pine any more than anything else, but white pine grows fast because of that green stem and the leaves that photosynthesize in April and May, early May. So it has an advantage. It grows fast and it occupies space quickly, and then that space is not available for the reestablishment of invasive plants. So you don't need to plant something, but sometimes if you have a semi-open area and you treat the invasive plants, they'll come back. So then you treat what comes back, and then you treat what comes back after that, and then you treat what comes back after that. And that's a very time-intensive, labor-intensive, chemical-intensive endeavor. And those plants can outlast you. So they can keep coming back, and after a while we wear down and they win. So if we plant something else and get something else growing, then maybe they don't win in that spot.
Do you have a specific strategy for treating bittersweet, or where would you suggest someone go for information for that?
Bittersweet is really tough. I had a couple patches of it that I actually logged how many hours I spent just on bittersweet, and it took me 5 or 6 years to finally get it. And part of that was that I used a mechanical treatment and a chemical treatment. And the chemical I used was the chemical I was using on buckthorn and barberry and honeysuckle and autumn olive, and that's glyphosate or Roundup. And that probably was fine for all the shrub species, but wasn't the best for bittersweet. Bittersweet tends to be able to shrug off glyphosate up to a point. And so it took me longer. And finally, I got the population to a point where I had cut all the lines at the ground level and pulled them out of the trees as much as I could, and cut down a lot of the trees that were heavy with the vines. The trees were kind of all bent over in kind of a canopy of bittersweet, and cut those trees down, pulled all the vines out, pulled them into a place where they were not going to be able to spread, where I could kind of watch them, be sure nothing grew from the severed plants. And then I went in with a shovel and dug the roots up. And that was an education, because there was way more root mass than I would have ever imagined there could be. The roots of bittersweet are yellow. So when you dig them up, you can tell them from other roots of other plants that might be in the area. They're bright yellow, like golden yellow. and I would actually kind of pull them up and work them up and pry them with a shovel. And when they would break off, I dabbed the little root end with glyphosate. And I'd keep going back every time they would sprout from the roots, and there would be a little plant that would be maybe 8 inches or a foot tall. I'd go in and clip it off with a pair of clippers and treat the root, or I would again go in with a shovel and dig it up. And I mean, tens of hours in an area as big, twice as big as your living room. And each year for years. And finally, I got it. Although last year I found one plant in that area after 2 or 3 years not finding any. And I found it in other places on the land, just a plant here or a plant there. And I mark where they are, and I go back and I get my shovel and I dig them right up, and I walk those roots right out, because I know how nasty it can be if you don't do that. So that's been my experience. Bittersweet has been a hard one to deal with. I guess if you use different chemicals that are more toxic, you can deal with that, but I don't want to do that.
Great. A great resource for looking at different ways to treat invasives in Vermont is vtinvasive.org. So we'll type that into the chat box.
Good.
Another question, kind of looking at invasives too, is there's concern about emerald ash borer, and we're going to lose so many of our ash trees. And what can foresters and forest landowners do to manage this species? Or, do they just cut them all down? Is that what they should do?
Yeah. Well, there are different approaches. Cutting them all down is really not one that I think anybody is using. Ash trees have value. We work in our woods and we harvest value periodically from our woods. And what most foresters are doing, what most landowners are doing, is when they have a scheduled timber harvest and they have ash, and the ash is big and the ash is valuable, they're harvesting those trees. So ash can grow to be healthy and 20, 22, 24 inches in diameter and still retain its financial value. And in the past, we would leave those trees to grow to the full term. Now, with emerald ash borer all around us, if you were having a timber sale and you had 18 or 20 inch diameter ash that 30 years ago you would have walked by, now you don't walk by them. Now you cut them down and you send them to the mill. If you have, everybody's different, and not everybody does the same thing. Some people leave those trees because they want to. And, if you own the trees, you can cut them or you can leave them. And it's not right or wrong. It's just a different approach. If you have a big ash tree and it doesn't have commercial value, it's an old pasture tree, really doesn't make sense to cut it down. It might have some genetic resistance to the insect, probably doesn't. Let's not delude ourselves. Even those people that believe there is genetic resistance are talking about, maybe 1% of trees. And others are saying, not really, because what happens is you have 1% that survive the initial wave of infestation, but they're not healthy. They've been impacted by emerald ash borer. They're not healthy, and eventually they probably succumb, either because the insect kills them or because they become less vigorous and the other trees that grow in that place outcompete them and push them out of the stand. So the prognosis isn't good, but it doesn't, people often overvalue their trees. So from a financial standpoint, if you have a 20-inch diameter ash and it's a beautiful tree, goes up 20 or 30 feet without a branch, large diameter, healthy tree, that tree might have 300 board feet in it, something like that, 300-400 board feet, for which you get $150 a board foot when you log. So you're talking about $40, $50, $60 for that tree. So if you have a few of those trees and you decide to leave them, you haven't really sacrificed much. You like the tree, you just don't feel right about cutting it, leave it, just leave it. And small trees, nobody is cutting all the ash. If you have 6 and 8 inch diameter ash trees, nobody is cutting those trees. They're not worth anything, and they are worth something from an ecological standpoint. Nobody feels good about cutting all the ash down. The loggers don't, the foresters don't, the landowners don't. We all are heartbroken that we're losing this valuable species. So, to circle back, some people are salvaging the valuable trees when they have a timber sale on their planned. They're including the ash, and some people are, more aggressive at that than others. But nobody is really cutting all the ash because we don't want to see it go.
Great. Thank you. So another question is from Giovanni, who wants to know a little bit about deer and overbrowsing, and what's going on there, and how might we address that, and are there particular species that are being reduced by the browsing?
Yes, that's a really important discussion, and we've kind of gotten away from talking about overbrowsed by deer. But deer are a native species; they belong here. We all love deer, but like any other population of animal or insect, they can get out of balance. And so currently, there are more deer than the forest can sustain. And some people would argue with that, but that's, I'm going to say that there are more deer than the forest can sustain. And so what happens is you have those deer and they have to eat. And so they eat our flowers and they eat our shrubs, and they also eat our sugar maple. And they eat our red oak. And there are other species that they don't prefer. They'll eat the sugar maple before they eat hemlock, and they'll eat the red oak before they'll eat yellow birch. But there are some species that they like, and there's some species that they don't like for whatever reason. And they tend to browse those species preferentially. So if you had a balanced population, whatever that meant in a particular habitat, that is where the deer ate some of these species, but there were plenty of others to repopulate a new forest, it would be fine, because there have always been deer and they've always eaten sugar maple, and we've always had sugar maple. So that's been okay. But now we have so many deer that they've eaten most of the young sugar maple. And if any sugar maple gets established anywhere, it's, there isn't much of the preferred browse there for them to eat. So when there is a place with preferred browse, they congregate and they get it. And so we've kind of gotten to a point where not much can get through. And so then what happens is the other species that are there, ironwood, beech, striped maple, pin cherry, paper birch, yellow birch, they grow fine, and white pine, and those species will grow, and those are all native species and they're all fine. But what you're doing is you're pushing certain species out. You're making it really hard for them. The deer are making it really hard for them to be part of the next forest. So that's what's happening, and that's. I think the only way to deal with it is to control the deer population. So nature will control it. I mean, ultimately, if you get to a point where there's nothing for the deer to eat, you'll have mass starvation, and you'll have less deer, and then you'll have a window where these species can regenerate, and they will. But we don't want that to happen. So Fish and Wildlife tries to control the deer population with hunting. That's why they have different hunting regions, and why they try to regulate the take in certain areas, increase it or decrease it, and manipulate it how best they can. But that's complicated by the hunting population growing older, as they grow older, they're less likely to go up on the hill away from the roads. They're less likely to be as aggressive hunters, hunting day after day after day, dawn to dusk. And they're less effective. So there's less hunters, they're less thorough, they're less effective. And as they start to shoot less deer, they start to lose interest, and then you have less and less hunting. You have more posted land. The deer go to the posted land. They realize the hunters don't come there to shoot them. So, I mean, they're not stupid. And so, the deer just go to these areas where there is no hunting pressure, and then they come back into the other areas when the hunters leave. So it's a real problem. The hunters will tell you there's not enough deer. The foresters will tell you there's way too many deer. And, and the truth is the habitat could handle more deer if it was a healthier habitat, but because all the young sugar maples get eaten, there's not enough food for the deer, and the habitat is degraded. So, it's complicated. It's complicated. And I don't know if that answered your question, but we could talk a long time about that particular issue.
Similarly, in kind of a follow-up, how has climate change affected the regeneration of maple, or climate change in the deer and the regeneration of maple? Is that all interrelated?
It's all interrelated, and you can throw invasive plants into the mix. So you have, think of the effects of climate change as being, it's not obvious. We used to call it global warming, right? Because we were thinking of climate change as being warmer temperatures. Well, it's not that simple. The weather patterns are different. We get rain in different ways. That's another change that's happened, is we never used to get these really intense rainstorms where you get 3 or 4 inches of rain. It just wasn't part of our weather pattern. You seldom got more than an inch of rain in a storm. You got a lot of light rain, and you seldom got rain in the wintertime. You got mostly snow in the wintertime, mostly rain, during the growing season. And the rains were maybe more common, but gentler. And so with that in mind, think about the changes in the weather patterns, the change in the rain pattern, the change in snow pattern. Think about what's happening right now with bud break. So we have all of these hardwood trees in the landscape all around us, and they're just about to break bud. Well, think what that means. The bud scales separate, and these little tiny leaves that are folded up within the buds expand and fill with water. Well, where does that water come from? I mean, it comes from the soil, but where does the soil water come from? It comes to a large extent from melted snow. So as the snow melts, it saturates the soil. Shortly after, the buds break, draw that water up out of the soil and rehydrate themselves. If that water wasn't available because the snow melted a month earlier, or there wasn't as much snow and the soil was drier, then that means that the trees either can't fully refoliate, or it means that they do refoliate. There is enough water, maybe from spring rains and from the little snow melt that's in the soil, that they could rehydrate, could expand, the leaves come out, everything looks normal, but the soil is now much drier than it would have been 30 years ago when you had snow into, mid-April. So that matters, because once the leaves are out, the leaves need to use water that they take up from the roots to photosynthesize. The photosynthesis reaction is what drives life on Earth. And it certainly drives life for a tree. So, or any green plant. And what that is, just to refresh everybody's memory, it's water that's taken up by the roots of the plant, plus carbon dioxide taken from the atmosphere, plenty of carbon dioxide, no shortage of that, using the energy of the sun in chlorophyll, either in the leaves or the bark, to produce sugars and oxygen. The sugars are used to grow the tree. That's where the energy comes from to actually grow the tree. So, so climate change can affect that. Climate change can dry the soil and kind of take one of these essential elements, water and carbon dioxide. If you have a shortage of water, you don't have photosynthesis, you don't have sugar produced, you don't have growth of a tree. Now, that matters. And now here's another factor. Different trees can photosynthesize at different efficiencies. So some trees can photosynthesize in different light levels more efficiently. Some can photosynthesize with more efficiently, so they use less water. And so certain trees, under the new conditions of climate change, will be more efficient. They'll be okay. Other trees, not so much. So this natural species mix that we have in our forests, whatever it is around your place, in your forest that you go to and you see, it's been fairly stable for a long time, that mix. It fluctuates, but those same species are there in roughly the same mix. And that's changing. So some species are not as able to perform at the level they have traditionally performed at, and others are okay. So the ones that are okay, they'll take a bigger portion of the forest over time, and the ones that are having difficulty will be pushed out. And that's how climate change will affect our forests. That's why I'm seeing more red maple, and that's why I'm seeing more red oak. That's why I'm seeing less sugar maple over time.
Okay, great. Rich is wondering if you could talk a little bit about the role and importance of dead, dying, and decomposing trees in a healthy forest, and how to get more if your woods are too clean.
Oh, that's excellent. Okay, I'm just taking a note here because I want to hit all those points. So
Let me read it again?
No, I think I've got it.
All right.
There are a couple elements to that. One is that dead wood is an important part of a natural forest. So it's important in a couple ways. It's important from a habitat standpoint, because something uses that dead wood for habitat or food. And it's important from a soil standpoint, because ultimately that dead wood goes from being a live tree to a dead tree to a fallen tree to humus in the surface of the soil, and ultimately is incorporated into the soil and decomposes to a point where it's actually taken back up into trees or goes back into the atmosphere as carbon dioxide. But it's important in the soil, not only as habitat for soil microbes, which are important from a nutrient cycling and water holding capacity standpoint, but it's also important habitat for terrestrial organisms, that is above the ground, you know, like cavity nesting birds. If you have a dead tree, you'll have woodpeckers will colonize it, they'll make holes, then those holes will be habitat for small mammals and birds, or eventually large mammals. So I guess that's another one of these changes that I've seen. When I first became a forester, well, I learned forestry at the University of Idaho, which had Idaho has 9 commercial tree species. It's a very simple forest compared to what we have here. And it's a very commercial forest. The Forest Service at that time was like, you know, it was all about timber. And so the training that I got initially as a forester was, you know, kind of get those big, rough trees, unhealthy trees out of the woods, make room for tall, straight, thrifty, fast growing, you know, economically valuable stems. And there's been a 180-degree shift in 30 years. And that hasn't come from foresters. It's probably come from landowners and Fish and Wildlife and organizations like Coverts that have said, you know, hey, these things are important, and what you're doing is really oversimplifying the forest, and we need to have a more complex system, not a simpler system. And that's I think common belief now that that's correct. We should strive for complexity, not simplicity in our forest. One of the forestry professors that I had at the University of Idaho had a plaque on his desk, and it said that forestry was order from chaos. And that's kind of indicative of the mindset of the time. That was our job, was to make order out of chaos. And now what we try to do is we try to kind of have controlled chaos. And so big trees, big healthy trees, we should leave them in the woods, because not all of them necessarily, because everything needs to be in balance, but we should leave some, because where is the big, coarse, woody material going to come from if we don't let some trees die naturally? Or if we don't leave some large wood when we harvest, we have to do that too. I mean, because you have a cycle of organic matter that goes from the soil into the living vegetation and then back down into the soil. And if you interrupt it by harvesting too much, you'll deplete your soil of organic matter. Then you won't have the capacity to hold water. Remember how important water is. You can't just have, if you had beach sand for soil and you had water enter the system as rain, it would just pass through the system. The roots would not have time to get very much of it, and it would be gone. So it's important to have organic matter in the soil to act as a sponge to hold the water so that the roots have time to take it up. So that's kind of the way the natural system works. The organic matter in the soil provides a really valuable function, and the organic matter in the soil comes from the organic matter that's on the surface of the soil or in the standing vegetation, you know, that ultimately finds its way to the soil. So I'm kind of rambling. I don't know if any of that's making sense. But you have the habitat value for organisms that have habitat niches in big trees and rough trees and cavities within trees. And then you have that even as the trees are fallen to the ground, you have habitat for under fallen logs for snakes and frogs and salamanders and insects and mice and voles. And you know, the forest can be pretty dry and warm in the summer, and it's nice to have those places that are moist, and those places are often associated with dead wood, you know, especially big dead wood. So to summarize, it's all important. From a forestry standpoint, the current thinking for most foresters now is leave big trees, leave some big trees and never cut them. We call those legacy trees. Leave some big trees as recruitment for coarse woody material. So they might be trees that we would cut or that we would just allow to die. So we kind of keep our options open. You want some of those in the system so that you can replenish the soil with organic matter, and probably don't try to utilize every little twig when you have a timber sale. Leave some wood in the woods, and if it looks messy, well, you know, nature's messy. If you go into any forest that hasn't received any kind of management for 20 or 30 years, you'll see dead trees, tipped over trees. You know, I mean, it's crowded in places, it's dark and branchy and gnarly in places, and that's just the way nature is. And all of that has value ecologically. So I'm done rambling.
That's great. No, I have another question from Giovanni that wants to know, do you have thoughts on strategic coppicing of younger trees as a forest management practice as opposed to cutting older, larger trees?
I guess I'm not a fan of Coppice. Coppice was first developed in Europe as a firewood tool where you cut a tree, you let it sprout, and then you have a vigorous root system feeding all of these sprouts. They grow fast. You cut those sprouts, and you kind of have a continuous supply until the roots play out. It seems there's like a different philosophy to management with Coppice. So foresters typically use a couple different management systems, either typically even-aged management, which is kind of an agricultural model of how to grow a forest and manage a forest, multi-aged or uneven-aged management, which is more of a natural model of how to grow and work in a forest. And Coppice is like the agricultural model on steroids. It's like trying to it's like trying to maximize the biomass you take off of a piece of land. And to my way of thinking, that's almost like mining the organic matter in the soil. And I find it's not something that I would want to do, because I don't see how you could do that repeatedly and not deplete your soils of organic matter and nutrients. And it's like the doctor's credo, do no harm. And I think that we have to have that in forestry too. Whatever we do, we have to be sure. Sometimes we don't know if we're doing good. We think we are, but we often do know when we're doing harm, and we shouldn't be doing anything that's not having a positive impact long-term on the forest. And Coppice, you know, to me, it's a little too much.
Okay.
Just my personal opinion.
Great. Another question came in about treating invasives, and they want to know, when you stump treat honeysuckle or buckthorn, is there a risk of killing a tree that has roots that are intertwined with the invasive?
No, not really. Not really. It depends how careful you are. If you're kind of like, usually when you do a stump treatment, it's very controlled. You're putting a small amount of herbicide directly on the target, which is the surface of the stump. So there's some techniques. One, when you bend over to make the cut, it's easy to make the cut at an angle. And then when you put the herbicide on that sloped surface, some can run off. And usually it runs down the stem of the plant you just cut and goes into the soil right there at the base of the stem. But what it does is it forces you to use more herbicide than what you should, and it wastes it. It puts it into the soil where it's probably not harmful, because at least with glyphosate, it binds to the soil quickly and it degrades fairly quickly. But you don't want to waste it, and you don't want to be applying it. You don't want to put any more into the natural system than you absolutely need to kill the plant you're trying to kill. So if you make a horizontal cut, the herbicide generally stays right there on the stem. You can almost watch it be absorbed into the stem, and it really shouldn't be touching anything else. And it's not going to be absorbed through the bark of a neighboring tree, because it's not going to touch a neighboring tree or bush. Not that it isn't possible to do some damage somehow, but really with a cut surface treatment, it's pretty localized right there on the surface of the target plant.
Great.
Now there are other herbicides that can translocate, that can cause damage. Glyphosate, which is the most common herbicide that we use to control invasive plants, won't do that. Won't transmit via. You're not going to have root grafting between different species or something like that, so it wouldn't be a concern.
Okay. I'm going to jump back to coppicing for a second. So someone wanted to know if you would thin or cut out trees that are already coppiced.
Yeah, you could do that. I think that if your goal is to grow certain stems to be big trees, that's one thing. But in the classic sense, what would happen is they would cut these stems that would sprout. They would let them grow to be 3, 4, 5, 6 inches in diameter, and mow them down, let it resprout. And every time they would grow, they would cut them down. And you could say, well, that's kind of what we do in our forest anyway. It's just we do it on a longer scale. We grow all these trees, and then ultimately we cut them all down. But we don't really do that. We don't really cut all of them down. And it's such a long period of time that there's a lot of ecological benefit. And the Coppice tends to be one species. I mean, whatever it might be, it's generally the species that sprout fastest or sprout most vigorously. Not every species does. So if you cut certain trees and they sprout from the root collar or from the stump, you can have multiple stems. You could pick the best stem, and they're not as structurally stable, but that's okay. I mean, that's just that would be fine. But if you were just like growing trees like your lawn, where you were growing all of these sprouts and then you were mowing them down, and then you were going back in 10 years or 20 years and mowing them all down again, and then again go back in and just keep doing that, that's the Coppice that I find objectionable, and that's what I referred to as mining the soil. So that's maybe we're talking about different things.
Alrighty. Donald wants to know what tool you recommend using when applying glyphosate to an invasive stump. Pour it, put a syringe.
Yeah, I know that Ethan Tapper uses his buckthorn buster, which has a sponge tip. And I have found that the sponge tips on the applicators that I've used don't hold up, because when you cut a stem, it can be a little coarse. And when you dab it or rub it with the sponge will eventually tear, just like your kitchen sponge will eventually wear out, that you use for your dishes. So what I use is a mustard bottle. The old mustard bottles, I don't know if they even make them anymore. They were yellow, they're kind of conical. They had a top where you could twist the top, and it would adjust the aperture so that you could have more or less opening at the top. So it would change the opening size. And so what I do is I have this mustard bottle. It's got herbicide labeled on the side of it, and it's durable plastic, and it's got this adjustable top. And I just open it a little bit, and I squirt the herbicide onto the stump, and then I close it. And that's kind of what I do. And I think everybody does it a little different. Some people have other kind of lab bottles that have their plastic bottles, like maybe a quart-sized bottle, and it'll go up and it'll have a top that goes up and then turns down, and they'll use that to squirt. But I've never found those they don't really work for me. Some people will use like those, if you go to some restaurants, they'll have ketchup dispensers on the tables that are pretty big, and they have they're plastic, and you squeeze them and the ketchup comes out. Well, you could squeeze them and have herbicide come out. Generally with glyphosate, you have a concentrated product that is generally 40 to 50% glyphosate. And the label tells you that you should either dilute it by 50% or use it at full strength. So if you dilute it with water, to 50% strength, it might be just as effective, but it's really watery. And so it's easy to over apply it. When you give a little squeeze, a lot of juice will come out. If you leave it as a full concentrate, it's a little thicker. It's not as thick as maple syrup, but it's a little less thick than maple syrup. You have to squeeze more, and you have a little more time to adjust how much you put on that little stump. So, I mean, those are just, that's how I do it anyway. And I think everybody does it a little differently.
Great. Well, thanks for that, Dave. I will say we've rounded out our hour. It's now 10 o'clock.
Oh, no.
Thank you all for participating in today's Coffee with a County Forester. This has been a weekly event with Vermont Coverts and Vermont Woodlands Association hosting. And this week we featured Dave Paganelli, our Orange County County Forester. Next week we'll have Hannah Dallas, who is Southern Windsor County Forester, answering your questions as well. I did put in the chat box, if your question wasn't answered, I put Dave's email address. You're welcome to email Dave, or if you're not from Orange County, or you can email both your local county forester and Dave. They love to provide information to you. Dave, if you have any last minute words, I'll let you add those, and Kathleen as well.
I would just like to say, well, thank you to everybody who participated. And even though we talked about some negative things, invasive plants and deer browse and invasive insects, the world is changing, but it's not ending. So we have a lot of change, but plants will adapt. We'll still have a forest. It's still wonderful and beautiful, and it has all kinds of life in it. And so even though there are some negative elements here, the overall is that we have a beautiful place to live and a beautiful forest in this place. So
Thanks, David. Kathleen?
Yep.
Dave.
Yeah, I would just like to say you could check the Vermont Coverts and Vermont Woodlands websites for other such events. We're doing a lot of different things on the internet these days, a lot of Zoom workshops and Q&A and presentations. So if you want to stay connected with what's going on, check our websites, sign up for our e-news. Lots of things to do while we're all at home.
Thank you
Great.
so much for all you do. You too, Lisa.
Thanks, Ann.
You're welcome.
take care, everybody.
Pleasure.
Bye all.
Thank you,
Thanks for joining
Dave.
us.
Bye.
See everybody. Bye.
Bye, Ann.